All right, welcome back. So let me go ahead and describe some of these worst mass wasting events in U.S. history. Excuse me. But before I do, let me give you another part of the super secret code. I'll say it just one time. All right, it's the number 8. Mount St. Helens, 1980. Excuse me. Let me go back. So when the volcano erupted, it created a landslide. It created debris flows. It created a lot of things, but it wasn't, it's natural because it's nature, but it wasn't just a natural on its standalone landslide. So that's why some people are like, is it classified a mass wasting event? Is it not? So I threw it in here. So it's the largest mass wasting event in U.S. history, but again, due to a volcanic hazard. There was landslides, there was debris flows, which resulted in deaths of dozens of people. Overall, 57 people died in the event, volcanic eruption, mass wasting. So 57 total fatalities between the eruption, mass wasting, floods, and ash. And in fact, autopsies showed, for the people that they found, that most of the people killed in the eruption likely died from asphyxiation after inhaling hot ash. So that's choking to death from just inhaling hot ash. So that's where most people died. So the volume of material that kind of came off of the mountain was 2.3 billion cubic meters. 2.3 billion cubic meters is the volume of material. And the slide material was deposited up to 17 miles down the local river valley, the North Fork Toutle River Valley. So it went for 17 miles. So remember that the Marcus landslide went for about 4,000 feet, which is less than 1 mile. This went for 17 miles. So here's Mount St. Helens, and here's all the material. This is just what's at the base of it. This is just what's at the base of it. It seemed to even bury almost whole other mountains, smaller mountains. So quite fantastic to think about. So then Bingham Canyon, Utah. So you can actually, this is a picture of it in action. So if you look at this area, it might look a little weird to you, but this is actually a mine. This is a mine. So this is just outside of Salt Lake City in the largest open pit copper mine in North America. More on mining later in the semester as well. But the thing with this one, there were sensors embedded in the wall to detect any type of stress in the rock. There was lasers at the rim of the mine pointing at the walls or the mine faces to detect all of this to detect any movement. So it was. So the movement was detected. There was some movement a few days before this happened at up to about 2 inches a day. So they said, everyone out, this is going to happen. So they knew it was going to happen. This was the largest natural mass wasting event, so not caused by another hazard in modern U.S. history. But is it natural? Because if the mine wasn't there, then this probably wouldn't happen. So you can debate that all day long. So the volume of material here is about 55 million cubic meters. That's only 2.4% of what Mount St. Helens was. It did register a 2.4 magnitude earthquake in nearby Salt Lake City on the Richter scale. No injuries, no deaths, since they knew it was coming. Mine operators had evacuated the site days earlier. So even though it was the most material for a standalone mass wasting event, no one was injured or hurt. But as so often as it is in places that have mass wasting events, so that was back in 2013. Now look at 2021. Same thing happened. Another mass wasting event. You build these steep sides of loose material. Well, stuff's gonna happen. Stuff's gonna happen. All right. So Gross Ventry, Wyoming. I hope I'm pronouncing that correctly. 1925. So the north end of Sheep Mountain, that's what that was, which overlooks Jackson Hole, Wyoming, famous skiing and resort area outside of Yellowstone National Park. One of the wettest springs on record in the region happened in 1925. So this was the second largest natural slide in terms of volume. Again, you could argue whether or not the mine was natural since kind of humans made that big hole. So 38 million cubic meters of material, which is only, again, 1.6% of Mount St. Helens. The slide formed a dam that consequently burst flooding the tiny village kind of downstream, killing 6 people. So the slide itself didn't kill anyone, but the slide itself dammed up a river, and then that river kind of bust through the natural dam and then flooded downstream and eventually killed 6 people. Thistle, Utah, 1983. So again, you can see this mass wasting event also kind of dammed up this river, and then some. So this is the costliest mass wasting event in U.S. history. Anywhere from $200 to $400 million in 1983 in damage. So that's probably up into the billions if you think about nowadays costs. The volume of material here is 15 million cubic meters. So that's only 0.65% of Mount St. Helens. The event caused a lake 160 feet deep to form behind it because it kind of formed a natural dam, damming up a stream. And the flooding wiped out the town of Thistle just below it. It also buried several important transportation routes. A railroad had to be rerouted. So a lot of that damage not only to the town but also to transportation. That's what caused a lot of the damage. So here's, again, that mass wasting event. Between these 2 mountain peaks is where that lake formed. They had to reroute the whole railroad through the mountain. So, yeah. So in this case, I don't know if there was any recorded people, deaths or injuries, but it did cause, some costly destruction. Alaska, 1964. So there was a lot going on in Alaska in 1964. There was an earthquake that occurred, magnitude 9.0 on the Richter scale. If you remember back to the section on, or the unit on earthquakes, earthquakes 9 or above, there's only been 5 in recorded history. And this is one of those. So it was a big, big, big earthquake. But it also resulted in large mass wasting events, both above and below the ocean, both on dry land and underneath the water. So there was some underwater mass wasting events at depths of 800 and over 1,100 feet deep. And so what happened, the underwater landslides, the underwater movement of this material, think back also to the Yunnan tsunamis, created some tsunamis. So in this case, it wasn't the plates moving and rebounding back that caused a tsunami. It was a kind of this movement of material under the ocean that kind of created these tsunamis, and the tsunamis raced from Alaska all the way down to California and Hawaii. There was 139 total fatalities, but that's with the earthquake, with the tsunami, with the mass wasting. So there was a decent amount of stuff going on there. So there is a convergent boundary. There was some uplift and subsidence, but it was actually over here in this area where there was some underwater landslide that ended up creating these tsunamis that raced out and then out of these little areas in Alaska and then down to California, down over into Hawaii. So you can see kind of before and after. Before and after. These are sub-ocean profiles, so you can see the continental shelf coming out, kind of coming on down. You can see this is the area below water that failed, and then they have kind of these underwater land maps of what the area looks like. So again, this is kind of that same area that failed, and you can see other landslide deposits underneath all that water. And then we get to La Conchita in California in 1995 and 2005. Like I said on the Bingham Canyon one, so often places where there's been mass wasting events, you'll get others, whether it's deep into in the past or future, or really close right next to each other. So, in 1995, there was a landslide, and in 2005, there was a landslide. So this area, the community of La Conchita, is right on the coast in California. Very desirable place to live, right there, right on the beach. But if you look, you have flat beach, kind of housing community built into this area. These steep slopes. If you look at the material of this, you can see that it's looks like loose material. There's a lot of vegetation up here, avocado orchard, so a lot of trees, a lot of heavy trees putting weight on this slope. You add a little water into the mixture, you're going to get landslides. There was landslides. They knew of landslides before. So there's prehistoric landslide. Here's an active landslide. This is from 1995. This is from 2005. And even though the 1995 one was a little bit bigger, it was the 2005 landslide that actually was the worst one. So let's take a look at what happened. So in 1995, 9 houses were damaged and destroyed. No injuries, no deaths. 2005, the smaller one, it reached into that community a little bit further. 46 houses were damaged or destroyed, and 10 people died. The material there was only 0.2 million cubic meters of material, so that's 0.009% of Mount St. Helens. Yet, it still did all that damage. So it's the second deadliest mass wasting event in U.S. history. So after the 1995 event, a study was done, and it showed landslides were common there. Go figure. And that complete stabilization of that slope would be about $150 million. Well, there was other ideas and other people telling them, what to do. So they went with a less costly strategy. I don't know exactly what that was, but they didn't go for the full, hey, let's fix this permanently. Let's go, well, let's just put a Band-Aid on it. Well, 10 years later, 2005, another landslide happened. It showed whatever they chose to do was ineffectual. Here's the stupid part. It's still a very highly desirable place to live. What's going to happen probably in the near future? There's going to be another slide there. Property values dropped after each landslide, but give it a few years, they bounce right back up. People have a short-term memory. All right. So this was a couple years ago that I actually found this on Zillow. Zillow is a website you can go to check out home prices. So this is La Conchita. Here's the hill. Here's the avocado orchard on top. You can see the kind of landslide material. So this was 2020. So remember, these landslides happened in 95 and 2005, so it had been 15 years at this point. There was a couple of things for sale. There was a property for $215,000 and a house for $1.78 million. Let's see what we can get. So for $215,000, all it was is just an empty lot. It's not this house. It's just this empty lot. That's it. For $215,000, you can own an empty dirt lot. Hooray. And you can see, if you look back up at the slope, you're looking up at the part that's landslide. That's landslides waiting to happen, right? But for $215,000, it can be yours. What about this? Right up against the hill, right on the hill. At least this land is kind of just a little bit off, but still at the toe of where that 2005 landslide came in. What about this one over here? For $1.78 million, you can own this nice little house. There's the slope. There's the hill right behind it. I wouldn't live there. And then we get to Oso, Washington in 2014. Your assignment for this unit will really focus on this, but looking at this kind of rotational landslide that occurred here. It covered 40 homes and other structures. It's nearly as well as a mile of State Route 530. 43 fatalities, deadliest in U.S. history, strictly due to landslide. It occurred in an area of known landslide activity, but, people roll the dice. But this time it was just bigger than anything anyone had ever imagined. Traveled further, much more destructive than anyone could have imagined. It also blocked a river, which also created floods, which helped to destroy more homes. Precipitation in that area in February and March was up to 200% more than usual of the long-term average, and obviously that contributed to landslide initiation and mobility. And just to see the head scarp of it compared to some of these large trees. But again, very loose material, add some water to it, steep slope, heavy vegetation pushing down on it, you're going to get a slide. So let's go ahead and pause here. When we come back, I think we should be able to finish up this unit. I'll see you then.